Hello, and today we're going to look at arithmetic sequences. An arithmetic sequence is a sequence that increases or decreases by a constant amount. That is, it goes up or down by adding or subtracting from term to term. So you add the same amount or you subtract the same amount to get to the next term. So the sequence below is an example of an arithmetic sequence, 2, 5, 8, 11, and 14. To show an examiner that this is an arithmetic sequence, work out the common difference between each number. That is what we're going up by. In each case, we're plussing 3 to get to the next number. We say our common difference between term to term is 3. You must show the examiner this in order to get the marks. To show a sequence is not arithmetic, we're going to do something very similar. We're going to start by looking at a sequence which could be mistaken at a glance for an arithmetic sequence, but isn't quite one. So the sequence we're looking at is 2, 4, 6, 9, and 11. Now, to show it is not an arithmetic sequence, work it out the same way above. Show term to term. So 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 3 is 9, and 9 plus 2 is 11. Now, this is no common difference, because one of the common differences is 3. Because it's different from the rest, we say there is no common difference. This sequence is not arithmetic. And again, I'm going to look at one more sequence which could be mistaken for an arithmetic, but is in fact not. This is an example of a geometric sequence. A geometric sequence is where you increase or decrease by multiplying by the same amount from term to term. So looking at the sequence 2, 4, 8, 16, 32. To go from term to term, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. Now, this is multiplying, not adding, to go from term to term. It has to be adding or subtracting to be arithmetic. So this is not arithmetic, it is geometric. But we'll look at geometric sequences in detail another day. So, basic notation for arithmetic sequences. You need to know this both for A-level and a GCSE. So your first term is often called U1 or simply A. A is your first term in your sequence. The second term, or U2, is A plus D. Plus D is our common difference. So if our first term is A, we simply add on D to get to the next term. Remember, you add or subtract to go up or down. The third term then will be D bigger than the second term. So the third term, or U3, will be A plus D, which was our second term, plus D again. This can be simplified to be A plus 2D. Our fourth term is very, very similar again. It's going to be A plus D plus D plus D. Or simply A plus 3D. Now do note in each case there is always one less D than the nth term. So the second term has 1D, the third term has 2Ds, the fourth term has 3Ds. For each term you've got, there is one less D. So the nth term is going to be A plus D plus all the way up to D, and there are going to be n minus 1 amount of Ds. Now we can simplify that into a very easy formula by writing A plus n minus 1 amount of Ds. So A plus n minus 1 in a bracket times D. This is our nth term. You need to know this both in your GCSE and in your A-level. Memorize it and learn how to use it. It is very important. Now we're going to use this formula in an example. So in an arithmetic progression, our third term is 8 and our 21st term is 44. That's what U3 equals 8 and U21 equals 44 means. So I'm going to start by writing our third term in terms of A and D. 8 is A plus 2Ds. The 21st term is going to be A plus 20Ds. Remember, there's always one less D than the term. Now I'm going to solve both of these simultaneously. So I've got 8 equals A plus 2D and 44 equals A plus 20D. Write them one above the other, put the biggest one on top. So 44 equals A plus 20D on top. Directly under it, I have 8 equals A plus 2D. And I'm going to subtract them. Subtracting shouldn't be a problem for you at this stage, I hope. So 44, take away 8, should give you 36. take away a cancels out. And 20Ds take away 2Ds is 18Ds. Divide across by 18, so 2 is D. And work out a by plugging D into one of your previous questions, and you should have a is 4. Now, that means the common difference is 2, and the first term is 4. So our nth term, I'm going to use my formula for my nth term. Again, that's a plus n minus 1 amount of Ds. I'm going to substitute my values for 4 and 2 into this. So I have 4 plus n minus 1 amount of Ds, or n minus 1 times 2. Multiply your brackets out. So you should have 4 plus 2n. Subtract 2 and simplify it down to 2 plus 2n. And there's our nth term. Now, to find the 37th term, simply use the rule you've just worked out. Plug in 37 in place of n. So the 37th term is written as u37, and that's going to be 2 plus 2 times 37, which I believe is 76 when you're finished. Now, a very similar example. In this case, our 4th term is 7 and our 18th term is 56. If you would like to pause the video and try this one yourself and then hit play and see if you get it right, feel free to do so. Otherwise, follow along with my narration. So our 4th term is a plus 3 amount of Ds. Our 18th term is a plus 17 amount of Ds. So 7 equals a plus 3D and 56 equals a plus 17D. As before, I'm going to solve these simultaneously. So write the biggest one on top and the smallest one underneath. So on top we have 56 equals a plus 17D. Underneath that we have 7 equals a plus 3D. And again we're going to subtract them. So 56 subtract 7 is 49. A subtract a disappears again, and 17Ds take away 3Ds gives me 14Ds. Now, divide across by 14. 49 divided by 14 is 3.5. So our common difference is 3.5, and if you substitute that back in to either of your previous equations, you should also work out that a is very similar to that, is minus 3.5. So D is 3.5, a is minus 3.5. Now, to find the nth term, again, I'm going to start by writing down my nth term rule. Always write down the rule first, then substitute your values in. A plus n minus 1D, plug in our values for a and d, so minus 3.5 plus n minus 1 times 3.5. As before, multiply your brackets out, so negative 3.5 plus 3.5n minus 3.5, take care with your minus signs, so you should have 3.5n, take away a 7, or minus 7 plus 3.5n, it's the same thing. Then to find the 52nd term, as before, simply put in 52 into your previous answer. So you should have 3.5 multiplied by 52, subtract 7. That's very straightforward. That should give you an answer of 175. So to find the number of terms in an arithmetic sequence, for example, 4, 9, 14, all the way up to 229, we start by identifying the first term and the common difference. In this case, our first term is 4, and the common difference is 5. I can see that all the numbers are increasing by plus 5. And what we're going to do is work out the nth term of the sequence. So we're going to start again with our formula. Un equals a plus n minus 1d. And again, I can't emphasize enough how important this formula is. You do need to know it. Plug in your numbers. 4 plus n minus 1 times 5. Again, multiply out your brackets. 4 plus 5n minus 5. Simplify it down. So 5n subtract 1. From there, I'm going to put the number 229 in place of un. I'm going to work out the position of 229 in the sequence. So 229 equals 5n subtract 1. Add 1 to both sides. 230 is 5n. And divide by 5. So 46 is n. This means that 229 is the 46th number in the sequence. So there are 46 terms in this sequence. Very straightforward. And one more example. The first 3 terms of an arithmetic sequence are 3x, 20, and 5x plus 2. We're going to find the value of x and the values of the three first terms after that. Now, this one is a much more difficult example. This is more of an A-level type question, although it is within the realms of possibility. It might be a GCSE question too. We're going to start by looking at the common difference. So 3x up to 20. To do that, you would do 20 subtract 3x. 5x plus 2, take away 20, will bring me the difference between 20 and 5x plus 2. So we're looking at the differences between the numbers. I'm just simplifying the difference there to 5x minus 18. So the first step is to find the difference between the numbers. Now, because these are both the same as your common difference, you can solve them simultaneously. You can set them equal to each other because they are the same thing. So 20 subtract 3x is the same as 5x minus 18. It's a simple bit of algebra from here. Add 18 to both sides and add 3x to both sides. So 38 equals 8x. Divide by 8, so 4.75 is x. From there, if I look at my sequence again, the sequence was 3x, 20, and 5x plus 2. I'm going to substitute 4.75 in for those values and work them out. So 3 times 4.75 is 14.25. 20 is still just 20. And the next one is 25.75. To check that I'm correct, I'm going to work out the common difference. It should be the same because it is an arithmetic sequence. So the difference between 14.25 to 20 is 5.75. And the difference between 20 to 25.75 is also 5.75. As the common difference is the same in both cases, this must be the correct answer. And it's finished.